In the last tutorial on ARDELA, we developed a program where we were able to calculate the area of marble in a project. In this particular ARDELA tutorial, let me go over the same program a little bit slower, and so you can get an more idea about how ARDELA works. ARDELA is actually works very similarly, or you can say it works same as Prolog. And internally, there's a Prolog interpreter engine inside TAD, and you can write programs to in Prolog syntax to do whatever you want to do. In this case, we were calculating the area of total marble usage there. Before further get into the to what Adela is, let me assure you that this tiny little program which we wrote, which is hardly some 28-30 lines, would be handling any number of objects. So even if I were to load a very large project with lots of objects and then only a few of them has got marble, it will intelligently go and figure out which are the ones which has marble and give you the area for those. So now let me break this down. When you do Ardella programming, in this case, when you're using the interpreter which is built into the into TAD itself, what you do is you have to create a special object. I mean, you can name it whatever you want. That doesn't matter. I can even rename it in the middle of this thing. I can call it whatever I want. It will still work because what it does is that what is written inside it is what it's searching for, and it starts its execution from this keyword called run. The bulk of the program which you write would be in this particular object. In this case, it is in CD1. And just to reduce confusion, I created a class called code to keep that object, just so that I can separate it from the actual model of the building which I'm working on. So this code has got an object called CD1. If you want to be picky, you can say that this object is actually a pseudo object. It is not really a building object. So you can label it pseudo. In some situations, TAD intelligently figures it out that this has to be really ignored and not used as part of the building model. Anyway, so coming back to this code here, so that's what you do. The main program is written here, and when I write this particular program, I may want to invent some functions if those who are coming from other programming languages, but they are technically known as predicates in Prolog. They're not. They don't. We don't use the word function in Prolog. So these predicates are defined in the same location. If you want to be more picky, you could create more CD objects, code objects, and keep it modularized in separate areas so that it may be convenient in some situation. In this case, I put the main part of the program along with the predicates which I happen to create. All of them I kept it in the same code object. That's your choice. What you want to do. Now, how that works is that if you notice, if you remember the last tutorial, what it did is that it actually I invented what is known in Prolog as a fact. Now, this is the most interesting part about TAG, that you can invent facts on the fly. And in this case, I invented a fact called hasFlooring. Now, you may wonder what made me think about this particular word. If you noticed in my earlier tutorial, I briefly mentioned that if you want, you can call it a hasFLR or hasFloor or whatever. And but I then ended up choosing hasFlooring as my invention because it sounded good enough for representing a particular fact that this particular object, which is represented by this at the rate sign, it stands for that particular object, whichever it's pointing to, and that has a flooring of marble. Now, this, strangely enough, is considered as predicate logic. Now, let me go here and show you that predicate logic, what is there in Wikipedia. So, predicate logic, this is the interesting part, that there exists X such that X is Socrates and X is a man. Now, this is a damn weird way to say that Socrates is a man, but you're putting quantifier in between to pass on the logic. So there are this X is passed on. There exists X such that X is Socrates and X is a man. So this is a way you go around talking about certain predicate inside your uh, this thing. So let me translate that here. So is man X. Okay. What did it say? That exists a man. So exists. Now, this is a way to say there is some X is a man. So if I now say is a man Socrates, this particular fact will be agreed to provided this X exists. So somewhere you have to define that yes, Socrates does exist. So you have to write somewhere in your program, in your model, that Socrates exists. So if somewhere it found this, then this will be considered to be true. So this kind of logic is what Prolog does. So in this particular case, I'm saying that this object, which is this particular character, is not actually part of standard Prolog. It is part of TAD. It is part of ARDELA. And this at the rate sign indicates that where is this particular code written in? It is written for marble floored class. So what it says is that whatever objects belongs which satisfy this criteria of being part of this class, it has a flooring of marble. That's what it basically says. And this full stop indicates it's a fact. That means, I mean, just assume it is there. That's it. Because of this, what happens is that this particular information gets passed on to all the objects belonging to that class. And once it gets passed on to that, that gets picked up by this particular code. Now let me analyze that code and kind of dissect it for you. What Prolog does, and therefore what do you say, the Ardela does, is that it goes to this particular predicate. It says that okay, let me see if there is a fact called hasFlooring, and that at the rate sign, by the time it reaches here, it has actually got expanded into the class name and object name of that particular object which it is currently considering. So since we gave it for three different uh, objects in that particular building model, this has got three variations. One is for an object called doorway, the other one is called a simple room, and the third one is called if I'm not mistaken. Now, what this does is that it will take one particular fact, then it will make a nice formatted string saying that such and such thing has got marble. It will write that message onto that Ardela message window, and then it will add up that area and keep it available in a store somewhere. Then it does one curious thing called fail. Fail is like a guy who's got OCD, so he's not sure whether all the flooring has been covered. So when he fails, he's in doubt. So he goes back and checks, and sure enough, he gets the second object which has got marble. Then again, it does the same thing, and again it fails, and then again it does the third thing because it went back to check whether there are more alternatives for this. The advantage of Prolog is that unlike procedural language, the Prolog is considered as a declarative language. You just declare that there could be something called flooring somewhere, and I'm not sure how many of them, so you please fail and ask for yourself, are there more? So this kind of way of interpreting it makes it very, very rigorously exhaustive. It will not leave a single object in case without, it will not say that, oh, I missed one object or anything. This fail ensures that it goes all the way back here. It's called backtracking in Prolog's jargon. So it backtracks all the way back, checks for a more alternative, and does this. And as a byproduct, it keeps adding up that area. Then eventually it is exhausted this. There's no more flooring. So this whole thing fails. When this fails, it gets caught by the second definition of run. Now, this may be a little strange for people who are coming from other programming backgrounds like JavaScript or C or anything like that. So this is as if like that you defined a run twice. Actually, it is not being defined twice. It's a different clause body it's called. So once this body is fully failed, it comes and tries to execute the second clause body. In this second clause body, it finds out, okay, this is the last area which has been totaled up because of the earlier activities here, because of this add up area activity. Now it takes the totals it up, writes that, and say thank you so much, or whatever clever message you had given in the end. And that's what it finally did. So if I go and run that interpreter here, that's what it does. So it says marble flooring, doorway as marble, simple room as marble, MMS marble, and the total marble area is so and so. Thank you. That's all for the marble flooring here. And this is how a very simple introduction to both Prolog and ARDELA. It uses something called predicate logic, by which you declare facts. And the advantage of declaring facts is that you can actually invent those facts. Like I told you earlier, it's something which kind of makes people a little puzzled that how did you come up with this? Well, I can come up with anything. So I could talk about skirting, I could talk about uh, paint, I could talk about ceiling paint, I could talk about anything from practically which I need to talk about as facts available in that those particular objects. And thereby, this does not have any limitations on what you need to really inquire. It all depends on you as an architect. What are your priorities? In this particular example, I happen to be obsessed about finding out what is the value of a total area of marble usage. And like I pointed out in the earlier tutorial also, if you notice, this design is probably still not ready. I'm not really gone on finalizing where this particular new element is. Maybe I'm going to rotate it. Maybe I'm going to reshape it. Maybe I will add one additional vertex on that or something like that. So the shape has changed. Now, obviously, the area would also change. So there it is. The area indeed has changed. So this is like a nice intelligent assistant to you who's keeping track of what is going on in your design. And that's how Ardela works. You can do a lot more powerful programming by which you can take out probably the entire quantities of a building. How much ever the number of objects there may be in that particular building, you can still do that. Thank you so much.